video is how we combine sinusoidal functions with the same period. So let's say, for example, we were given two sinusoidal functions and we wanted to combine them. So I have y is equal to sine x plus cos x. And my goal is to get it written as in the form where it's just a single sinusoidal function. So I can either write it in the form of sine x or cos x. Let's do this one as sine x. And I know that when I combine these two functions together that there's going to be a new amplitude and there's going to be a new phase shift. Okay, so this is phi, and that represents what our new phase shift is going to be. So let's see what we've got here. So this is the form that I want to get it into. So let's keep going down with this form. Now, there's a shortcut to figure out what the amplitude is. So in order to figure out what this new amplitude is, the amplitude is going to be equal to the square root of the amplitude of my first function plus the amplitude of my second function. So in this case, it happens to be the square root of 1 squared, because my first function had an amplitude of 1, plus 1 squared, which is just going to be the root 2. So what I'm going to do is I'm going to take that root 2 now, pardon me, and plug it into that a value there. So y is going to equal root 2 times the sine of x minus phi. What I don't know, what I don't know is that phase shift. Let's just erase that crazy bracket. Okay. So what I'm going to do now is I'm going to expand this compound angle here. So I'm going to have root 2 times bracket sine x cos phi minus cos x sine phi. That's just our compound angle formula for sine. If we were finding the function and we wanted to put it in terms of cos, then of course you would use the cos compound angle here. And then I'm going to expand this root 2 through it. So it's root 2 sine x cos phi minus root 2 cos x sine phi. Okay, now here's the thing. Sine x plus cos x are combining together to give us this new function. New equation of the function. So this term plus this term are going to add together. So in the same way, let me just change colors here, this term here and this term here are going to add together. So what I can do is I can use these two terms from the original function and set them equal to each part of this new equation of the function. So I'm going to write this as sine x, and I'm going to write this one as cos x. Now, I chose this one as sine x because it matches up here, and what's eventually going to happen is they'll be able to cancel each other out. And cos x there. Sometimes the cos x would come first, the sine x would come first. It all depends on what the equation is that we're talking about. Okay, so at this point now, what I'm going to have is I'm going to have two different equations. Okay, so now I'm going to have two equations here. I'm going to have equation 1, which is root 2 sine x cos phi equals sine x, and negative root 2 times cos x sine phi is equal to cos x. And if I divide both sides by sine x, what's going to happen is that's going to become 1, and so is this. So I'm going to be left with root 2 cos phi is equal to 1, and over here I'm going to be left with root 2 sine phi is equal to 1, because I'm dividing everything out, both sides, by cos x, because it occurs on both sides. Okay, so now what I've got here, if I simplify this, I have the cosine of phi is equal to 1 over root 2. And over here, I have the sine of phi is equal to negative 1 over root 2. Well, this is just right back to solving a regular trig equation. I would then say, oh, okay, well, my related acute angle is equal to the inverse cosine of 1 on root 2. And over here, my related acute angle is equal to the inverse sine of 1 over root 2. Because remember, our related acute angles, we always make positives, so we don't consider that negative at this point. 1 over root 2 is the same as saying root 2 over 2, and we know that that's one of our special angles. So when is cosine equal to root 2 over root 2? Well, that's when it's equal to pi on 4. So my related acute angle here is pi on 4. So let's set up our cast rule. And if we look at the equation up here, cos phi is going to be equal to a positive value. So where is cosine positive? Well, it's positive in the A quadrant, it's positive in the C quadrant. So what that means is for phi, I have two different places where phi could be. Phi could be this value here, which is the related acute angle of pi on 4, or it could be this value way over there, which is going to be 2 pi minus pi on 4. So we have to decide which one we're going to use. In order to do that, we need to use our second equation. We need to say, listen, phi is only going to occur once. There's only one phi. There's only one phase shift. So let's figure out where that's going to be. And so taking a look at this, again, using the related acute angle, we know that the inverse sine of 1 over root 2 also is pi on 4. But in this case, this has an expression that's negative. So that means we ask ourselves, where is sine negative? Well, it's negative in the T quadrant and in the C quadrant. So we have to say, where is it the same? Where is phi? Where is this phase shift going to be the same in both equations? And you can see, just grab my highlighter here, you can see that it's going to occur here in equation 4. And so that's the terminal arm I'm going to consider. So now I know that my related acute angle is pi on 4, so that means this little piece right in there is equal to pi on 4. So that means that phi is actually equal to 2 pi minus pi on 4, which is 8 pi on 4 minus pi on 4, which is 7 pi on 4. Okay, so the other way we can also look at that is we could say, oh, or instead of going all the way around my circle in the positive direction, I could go into the negative direction, and I could say that phi is also equal to negative pi on 4 if I go in the negative direction. So what that leaves me with is, therefore, if I want to rewrite y is equal to sine x plus y equals cos x as just one function, I could write this as y is equal to root 2, because I figured out the amplitude way up there, times the sine of x minus whatever we had for phi. So in this case we had 7 pi on 4. Or if we wanted to use this way of writing phi, which is in the same spot, it's just going in a different direction, we could write it as y is equal to root 2 sine, and this would be x minus negative pi on 4, so it would be the same as x plus pi on 4. And there you go.